just introducing more tools into the proving toolbox, right? So as we talked about yesterday, we have certain tools that we're going to use when we are proving identities, right? And again, I did see some people try to start with an equal sign, and then everyone's like, oh no, I have to do it in the left side, right side chart. So it's I was glad to see that. So let's see which tools we have thus far. We've got, anyone remember what this one is called? Right there. Quotient. Yeah. Quotient identity, because we're dividing. All right. Then we have this one. What is this one called? Pythagorean identity, right? This is no different from what you were solving on the boards, except that these guys are the standards. These ones are the ones that you're going to use all the time to solve more complex ones. Then we have these tips, which are so important. So when there's that question of where do I start, I'm like, did that person read the tips again? Okay. Yes, Lila. Yes. So on the test, you will be given this, the yellow identities. And from today's lesson, you will be given something like this. Yeah. Absolutely not. The question was, will we be given the tips? I'm curious, which tips are proving helpful? Put your hand up, let me know. Liam.
The tan one, the common denominator one.
Okay, one sec. So tan, switching it into what? Sine over cos. Good. Greg?
Yeah, the common denominator.
Finding a common. So anytime you're adding and there is at least one fraction, you know you can make that one or anything. You can make anything into a fraction. Okay, what's another one? When you see something squared, a ratio squared, what are you thinking about? If you see a ratio squared, Pythagorean identity, excellent, good. Okay. So let's go to today's lesson. So all we're doing, conceptually nothing new, we're just going to bring in more identities, more tools. And so today what we're doing, you need to stop. Turn your body around. Thank you. Today we're going to bring in the reciprocal ratios. Okay, so we know that cosecant goes with sine, secant goes with cos, cotangent goes with tan. Some of my students from Miss Epper Jessie's class had a really good tip about how to remember which ones go together. For secant and for tangent, the last letter of the reciprocal ratio is the first letter of the primary ratio. So cot, tan, sec, cos. Okay, it doesn't work for sine. For sine, it's the middle letter. Do you know what I mean? Yeah? Okay. If that works, that works. Great. Okay, now watch this. Okay, because I just wrote this down and it's like, Miss Lai, how did you get that? So let's see. What I'm suggesting is that if I have cosecant theta times sine theta, I can rewrite the cosecant as 1 over sine theta. Agreed? Okay, you following? Okay, so write this down, right? This is going to be helpful. And when we multiply these two, we get sine theta over sine theta, which equals to what? 1. So when we multiply the reciprocal ratios, because they are reciprocals, they equal to 1. And that is a tool that we have in our toolbox. So when you are multiplying reciprocal ratios, the reciprocals of each other, they will equal to 1. Can anyone remind me what time class goes till? Is it 11 on the dot?
10:55, I swear. It's 11.
Okay, I'm going to go with 10:55 and then see what happens. And then alternatively, because we have the quotient law, there is also the quotient identity for for reciprocal ratios, right? So tan x cotangent x is sine x over cos. Well, cotangent is cos over sine, right? The reciprocal. Do we see that? Do you want to write that down? These are reciprocals, i.e. the fraction is flipped. Okay, you need to keep your body rotated so you don't get distracted. Folks, I see some earbuds in. Would it be helpful to take them out? Yeah, good. Now I'm going to add one more hint. Actually, let's go. I wonder if we have this hint here already. No. My hint is going to be, guys, can you stop? Like, you're going to listen to this recording and be like, why is Miss Sly always asking people to stop talking? Yes. Okay. The other hint is going to be to change reciprocal ratios into primary ratios, right? So if you have cosecant, you're going to switch it into sine. If you have cotangent, you're going to change it into tan. Okay, so another tip we're writing on a page 1 is change reciprocal ratios into primary ratios. I.e., if you have cosecant theta, we're going to write it as 1 over sine theta. Basically, we're trying to get everything into sine and cosine, just as a way of simplifying. We're getting rid of tan. We're getting rid of cosecant, secant, cotangent. Move everything into sine and cosine. Does that help? Make everything sine and cosine. All right. So now let's go and try out proving identities when we now have additional tools. Okay. Step 1. Okay, we're going to read this identity. Tan, cotangent, secant, cosecant. All right. So I'm going to make my nice and big chart. And both of them kind of look tricky, which is I'm going to break the rule of just work on one side because both of them are complex and both of them are not expressed in cosine and sine. So the goal is to get both sides into just sine and cosine ratios. So we have tan x plus cotangent x. And then we have secant x times cosecant x. So let's start on the left side, although we're going to end up doing a little bit of work on both sides. So when I see tan x, what can I write it as? Beautiful. So tan will be written as sine x over cos x. And how about cotangent? Yeah. Beautiful. It's the reciprocal. So I can write cos x over sine x. Do you see how I didn't even change the cotangent into tangent? I was just like, I can immediately switch it into sine and cosine. Now let's make sure we're using equal signs appropriately, right? So I'm saying this equals to that. Okay, what's the hint I'm going to use now? Beautiful. Find common denominators. So I'll just make, if it helps, I'll just make a hint. So here I used the quotient identity. Now I'm going to find common denominators. Okay, what do I multiply this first ratio by? No, I multiply by sine x over sine x, right? I multiply by the denominator of the other fraction. And what do I multiply the second rational expression as? Yeah, this one?
You multiply by the numerator or the denominator?
The denominator, the other denominator, right? So here, I'm multiplying it cos x by cos x because of the other denominator. Anyone see what's going to happen? What are we going to end up with? Yeah, that's right. We're going to end up with a 1 because I'm squaring some ratios. Okay, so sine times sine is sine squared x. I made the squared, the exponent orange, because I want you to notice where it goes. It doesn't go after the x. Now I'm just going to right away put it all in one big fraction. What is the common denominator? Well, it's cos x times sine x. So because they have a common denominator, I'm adding the numerators. And then when I multiply cos times itself, I get cos squared x. Now make sure you're putting the squared in the bright space. And then Greg was like, hey, sine squared plus cos squared is what? Show me with your finger. What is it equal to? Uno, muy bien. That is called the Pythagorean identity. So I've got 1 over cos x times sine x. I'm going to stop here, and I want you to tell me why I'm going to stop working on the left side. Yeah. But why am I stopping? Why wouldn't I keep working on the left side? So when you say you can't simplify anymore, give me more. Yeah, Sebastian.
The reciprocal of the right side.
That's one term.
It will be the reciprocal. Give me more.
I was actually going to ask a question. Could you go back just one step?
Yeah.
How did sine x squared plus cos squared x
Equal to 1?
Yeah.
Yeah. Remember this one? The circled one?
Oh, yeah.
Yeah. The more you do it, the more it'll just come naturally. Yeah.
That circle and beyond the text.
The yellow circle stuff will be you will be given. Now, folks, the question is, why wouldn't I say, hey, I know 1 over cos x is secant x. Why am I not changing it into that? Luke, why did I say stop? It's a 1,000,000-point question. It's another one. Million points. I know they're imaginary, but they're still worthwhile. Yeah?
Like the opposite side is like.
No. Yeah.
Cos x times sine x is equal to 1.
No. It's not. Yeah.
Because you don't want to switch into the reciprocal ratio.
Muy bien. 1,000,000 I points for you. Folks, stop when everything is sine and cosine. Stop. That's like one of those jump off the desk messages, except that I'm not dressed for jumping off the desk. Stop. Um, because you have, how do I phrase this? Stop, maybe when okay, this is really important, folks, because you're not gonna like these can get really messy, and you're gonna be like, how do I know when I should go to the left side or the right side? How do I know when I stop? So when we're talking about simplifying, we're talking about expressing these identities with sine and cosine. So if you are at a point that you just have sine and cosine, you're like, okay, can I simplify anymore? Meaning, like, can I use the Pythagorean? Can I make it shorter? If you can't, stop. Let's move to the other side. Now, let's try to get the right side to look like the left side. Okay, well, this is helpful. I know that secant is the same as 1 over which one? And cosecant is 1 over sine x. Oh, these are just, whoops, reciprocal ratios. And so when I multiply them, I get 1 over cos x sine x. This is a good place to stop. How do I finish off? Since left side equals right side, therefore, this is the really annoying part because I have to write the whole identity out. Tan x plus cotangent x equals secant x times cosecant x. See, Miss Sly, I proved it. Yes, you did. All right, let's look at the next one. And at this point, I feel like I need confirmation of when class is over. Is it 55?
Yeah.
Thank you. All right, we got 7 minutes. Let's do it. All right, step 1, let's make a big table. Both sides are equally complicated. So I'm going to start at the left side, but I know I'm going to have to do some work on both sides. Step 1, let's get rid of those reciprocal ratios. Okay. So it's going to look ugly, but I'm going to write 1 minus, what are we going to write? 1 over cos x. So not fun. Because now I have to find a common denominator in the denominator. Right? So I'm leaving the numerator. The cos x minus 1, I'm leaving that for now. I'm going to do some work in the denominator. So what can I write 1 as? Cos x over cos x. Right? That's the same thing as 1. Minus 1 over cos x. So we're ignoring the numerator for a little bit. Okay? Still ignoring the numerator. We just write it. And so now when I add them up, I have a common denominator of cos x. And then I'm going to add the numerators. Cos x minus 1. Where does this take me, Miss Sly? At this point, I am dividing a numerator by a fraction. So when I divide fractions, I can multiply by the reciprocal. Okay, watch what I did in this step. This one's a big one. Multiply by reciprocal of denominator. I'm going to add some brackets so we can see that since everything is being multiplied here, I can cancel out. What can I cancel out? We can cancel out cos x minus 1. Cancel, cancel. And we are left with a lonely cos x. What do I tell myself right now? Stop! Miss Sly, stop. Let's move on to the right side. Yeah.
Why did you put
So I am dividing the purple numerator by the blue denominator. So when you divide something by a fraction, it's the same thing as multiplying it by the reciprocal. All right, let's go to the other side. It's going to look similar. First things first, we're going to get rid of the reciprocal fraction, of the reciprocal ratio. So I've got cos x plus 1 over 1 plus, and I'll just use blue to show what's the difference. So instead of writing secant, I can write 1 over cosine x. Now, similarly to the other side, we're going to add the two fractions. So instead of writing 1, so again, I'm leaving the numerator as is, not really touching it. But instead of writing 1, I can write cos x over cos x. Max, I can hear you. Yeah. Hi. Okay, so we see that this is similar. Okay, let's add up the denominator. Again, leaving the numerator just sitting there. The denominator becomes cos x plus 1 over cos x. Once again, I'm dividing a numerator by a fraction, which means that I can multiply it by the reciprocal and cancel out. And I'm down to the cos x. So these kind of trig identities and a lot of the ones on your homework, you are going to have to work on both sides. Now, notice the homework is kind of huge. There are 26 identities. You might not get through all of them, okay? I will make a little video. Oh, I didn't tell you. Did I tell you that I'm not here tomorrow? Okay, I'm not here tomorrow.